Welcome to AFrame lesson 3.5. In this video, we're going to explore how we can detect if a collision has happened between two objects in our world. In doing so, we're going to explore a new attribute called Object3D and how to add events to our window. So let's get to it. So as a little motivation, let's talk about what we're trying to do here. So we want to be able to shoot a sphere at this box, and when the sphere collides with the box goes away. Currently right now the sphere is behind us, kind of like hiding a little bit. Let's take a look at the HTML. So we see we have the box, we have the sphere, each of them has an ID. Let's go over to our JavaScript, and you see that we've already pulled variables for each of those objects. We'll be manipulating them directly. So the first thing I suggest is that we solve how to move the sphere, the bullet. So we got a Z, a DZ, we're going to make it negative, and we're simply going to change the Z value of the bullet by DZ. So Z plus equals DZ, and because DZ is negative, it's going to go into the world. Now, up until now, you've learned how to change the position of objects in the world using the set attribute and the position attribute. There is another way of doing it, especially if you only want to modify one particular position in that position attribute. So there is something called Object3D that all AFrame components have. The reason for that is that AFrame is built on another library called 3JS, and in that library all components have this Object3D attribute, which then can be further specified as to which attributes, such as position, rotation, scale, and then go a step further and simply specify the particular position or rotation or scale. So in this case, we're going to take the bullet's Z position and simply match it to the Z value we have here. Let's test this out, and what we should see is that the ball moves. Great. But now we want the ball to move when we click on the screen. So let's add a shoot flag, set it equal to false. So let's say if shoot, and let's wrap this in there. And let's just test this out. Now, we're not going to see much on the screen, but that's actually a good thing. That means the bullet's not moving, because the bullet needs to wait for us to actually shoot. So in order to do that, we're going to add an event to the window, not to a particular object, which will allow us to simply click anywhere on the window. So let's add our callback function to our event listener. And at this point, we're going to say shoot is equal to true. So when we click on the window, shoot's going to equal to true, which will enable this if statement down here to work. Let's test that out. And there you go. I clicked on the window, and the ball went ahead and shot. I do want to cover something else, though. If I move off to the side, oops, do that again. If I move off over here, you notice that the sphere, the bullet, still is shooting from the original location. That's because when we shoot, we should also move the bullet's X position to the same position as the camera. So for that, we're going to have to grab the camera. So let's do camera, document, query selector. And let's grab that camera. And let's go ahead and make a variable appear for that. All right, so when we shoot, we want to be able to match the bullet's X position to the position of the camera. So I'm going to simply do a little copy paste there, say the bullet's X position should equal to the camera's X position. Let's give that a try. So let's move the camera a little bit to the left. And now we see that the bullet shoots from our location. Great. So now we're able to explore the last part of this video, which is the idea of collision. We got the bullet moving when we click, but now we have to check to see if the bullet has actually hit the box. Now, in order to do that, we have to explore another concept from math, which is the distance formula. Now, typically in a math class, you would have explored, using the XY coordinate system, but because this is a virtual world, we add the extra Z value to it. Now, because we're not necessarily moving the stuff up and down, we can take the middle part out because there won't be a change in the Y's. Everybody's going to exist in the same Y plane. So we're going to resort to just the change in X and the change in Z. So for that, what I want to do is I want to create a separate function down here to handle simply the collision between two objects. So we'll allow the function to accept those two objects. And now we're simply going to create the distance formula. Now, to save a little bit of time, I've already kind of typed this up because you really don't need to sit there looking at me type. And actually, I could get rid of this because I already had that. And I already got that. And let's just explore what's inside this function. So you can see here, just to simplify a little bit of our formula down here, I've created variables x1, x2, z1, z2, and they are the X position of the first object and the Z position of the first object, and the same thing with the object 2. Again, this makes it generic so that it's not necessarily just about the bullet and the box. This collision function could be used for any two objects. We can see here that in our math formula for distance, we take the square root of the difference of the x's squared plus the difference in the z squared. This last part is what's really deciding whether something's colliding or not. So I have made a decision that if two objects are within 1 meter of each other in this virtual world, then they will have collided. Again, if you're unfamiliar with this approach of doing a Boolean variable in a return, we could have easily done an if statement that said if the distance is less than 1, return true, else return false. All right. Again, I'll leave this as an exploration for you to kind of discover why this is a shorter way of doing the same thing with just simply if statements. So now what we can do is inside of our loop, we can create an if statement and use that collision function to test if the bullet has collided with the box. And we're going to take a small step here where we're simply just going to do a console log of boom before we go any further. All right, so let's hit refresh. Let's bring up our console log. I'll move over loops. Let me refresh on that one. Let me aim first before I shoot. And there we go. You can see here we got the word boom popping up a couple times. That's because as the bullet goes through the box, it's constantly colliding with the box. All right, so let's take the next step, which is that when the bullet hits the box, we remove the box. Now, the nice thing about this is that we could simply just take the box and remove it. All right, so let's see that. Let's move over a little bit and let's aim at the box. And boom, the box went away. So again, I'm going to pull up another example here that's a little more complete, just kind of show you the biggest inspiration here. So let's go ahead and refresh this one. And what this is an example where I dynamically create a bunch of boxes. And what I'm going to do here is I'm actually going to click. And you'll notice that anytime I click on one particular box, it goes away. Again, I'll show you a little bit of the code, but this is more for, an appreciation as to, where you can go with this. Maybe you could do uh, like a block breaker game. These could be things that are coming at you that you have to then shoot before they, arrive at your location and kill you. And last one. Actually, I think there's one over there, but that's okay. We could leave that one alone. All right, so let's go back to our presentation. Let's review what we've done. So in this video, we explored how we can detect if a collision has occurred between two objects by simply using the distance formula. We also explored how every A-frame component has this object 3D attribute, which gives us more direct access to attributes such as position and rotation, where we wouldn't want to change just one aspect of the position and the rotation. Finally, we saw how we can add event listeners to the window and not necessarily to a particular object. And this allows us to pretty much click anywhere on the screen. So hopefully you're excited about what you can do in your virtual worlds and enjoy.